Hey, it's Dr. Bab here to talk to you about Chapter 10, Business Intelligence Dimensional Modeling. So, what's the difference? I think 8 and 9 were far more important. These are some good, there's some good information here, I think, with respect to um, thinking more about dimensional modeling. But honestly, you just need to understand the difference of what's happening inside the tool, Tableau or Power BI, versus what's happening, out there in the operational data stores. So, let's get through some of this material, but I don't think we need to kind of be as concerned or dwell in here. And then I'll get a sort of a fixed quiz about this. The quizzes are coming out a bit late because I'm trepidatious on some of the difficulties importing I've had. So we're going to look at different hierarchies, different ways to kind of consider looking at fact tables, looking at change in dimensions, causality in dimensions, multivariate dimensions, dimensions that are really perhaps junk dimensions, just some thoughts, right? So this is advanced dimension modeling, and it's just kind of based on some observations from the authors. So I think the basics of dimensional modeling were probably the most important. If you think of, for instance, uh, one of the first points that Sherman makes is that a lot of dimensions are highly hierarchical, right? So a date can be subdivided or drilled down from a year, quarter, month, day. A product, of course, can come out of its own derivations in its hierarchy, or even there's geography, right? So we have to drill down to get more detailed granularity, or we actually start to aggregate upwards from the grain for aggregates. And so the idea there, again, is that since a lot of our data is hierarchical, it creates some, special concerns or special considerations that we have to take into account, particularly because the products of doing all this is usually dashboards and reports, and so we always end up having to drill down, right? And tools like um, Tableau were absolutely made for this. So if we look at ooh, I don't know if you can hear that as a storm outside. But if you look at uh, making these hierarchies, then the idea is that you want to think about balancing them in some ways, right? So the balance hierarchy is the simplest way to kind of think of these dimensional models when they're hierarchical, right? And they can be balanced, ragged, or unbalanced, right? And so um, this is a good example of a balanced. Um, we also could have, this is an example of uh, different ways you'd want to break up a hierarchy, right? To just seek other means of balance, right? Criteria for balance. But then we could have a ragged hierarchy where effectively, sure, there is, but there are some breaks here. So, for instance, we don't have the same concept in the European Union of a state providence, right? It's actually each individual country. And then we can just have, here's the example of a org chart, right? This is the highly unbalanced hierarchy. But these are going to have some implications for your reporting. So that's one of the first examples that is given to us. Another, of course, I'm sorry about all these notes. Another is um, we could have, because of these unbalanced hierarchies, we have variable depth hierarchies, right? And so when we're having to kind of use SQL queries or extraction, transformation, and loading queries, or even BI, we end up having this problem of, in this particular picture, my strategies for drilling down are not equal. So, for instance, this gives us this strangeness where we talk about this employee recursive example, where the employee has this employee key and manager key and sales territory key, and these actually become two different ways to have to drill in, right? But when we want to talk about a fact table for sales quotas, then we're actually having to look at the employee key back on itself, right? Because it's actually looking at sales territory as a different component. So what do these matter? And again, I'm not going to spend as much time on this video. This just is different considerations for the structure and nature of this data and how that's going to create certain problems. So that's one aspect of having a variable. And but by the way, these are solutions to this variable depth unbalanced hierarchy here. Another is that this is classic what you learn in database is you make bridge tables. So bridge tables allow you to take these many relationships and bridge them together, right? So there are many reseller sales and many employees, and we kind of reconcile this many to many relationship across these. There's another concept he talks about in the book of outrigger tables, and it's kind of a way to continue to extrapolate out the star schema. So outriggers are used when a dimension is referenced within another dimension. So when a dimension is being designed, all attributes that are related to each other are gathered into the sort of the first order dimension here, and then, of course, we have keys embedded in here just to be able to get to these outrigger tables, right? Or outrigger dimensions. So the fact leads to one dimension, which then allows us to break it out into further dimensions. What does this have to do? This has to do with the schemas actually aren't all cut and dry. And this just gives you a sense of what's going on. Now we also have slowly changing dimensions. So dimensions have attributes that change over time. So products have changes in price and cost and composition. Employees, change their status. Customers change their address and all that. So this stuff um, isn't really um, periodic, episodic. It's kind of stochastic. It's hard to predict, and you really have to find a way to kind of track these permutations to know you're talking about the same thing. So the idea becomes if we have a slowly changing dimension, um, and it's because the operational and transaction processing things have changed that, then how do we reflect those changes out to our dimensional design so that these can be retained? So we're between chapters 8 and 9, we kind of make this shift in our thinking from operational to analysis, right, to analytics. And as a result, we need some way to trigger kind of the historical change of state across this entity to kind of know, right, to know what's going on. So we end up having um, we kind of have this concept from the book of as was and as is, right? And there are several techniques that the book goes on to discuss what are you going to do to work with these changes, right? And so there are, in the book, he's calling them SCDs, so slowly changing dimensions. So um, the first strategy, of course, is a non-strategy. It's just basically saying, well, we just keep the original. So if there's a change, who cares? So that's not listed. The second, of course, is that we type one. So the book goes through. Let me just put them all in here. It'd be a lot easier if I just took an extract from the book and showed them real quick. So they're each of these slowly changing dimension types mentioned in the book, and I just kind of want to go over each one here briefly. So one is you keep the original. The type zeros keep the original. Type one is override existing data. Type two is create a new row for the new values. So we have kind of two records on well, if it's a customer. Track changes in a separate column, but overwrite the rest, right? So the idea is that keep track of the fact that there were old values. You can add in a mini dimension, and then we just have combinations of each of these types here, right? So it becomes strategies, component strategies, or composite strategies for each. So again, one is, let me put that back up here. So one is just, change it. So we end up having a schema that allows us to deal with that change, right? So that's a good example here. So we can have a facts table that links to that dimension that kind of tracks that change. And so this becomes kind of our way to, keep track of in our systems of record, which is what SOR means. So we kind of have this separate change tracking schema that we've made to really deal more for our BI tables, right? And it has to link back to the system of record so that we know how they uh, work with each other, right? And so that's what we'd have like right here. So the system of records surrogate key, and then there's the dimension natural key, and then the dimension durable surrogate key, which sort of says that, how do we know that this is like the same thing? So the dimension natural key might have changed, right? And we want to be able to keep track to whatever that change record is out there in the system of record. But this is still customer BAB, and so as a result, I don't care how many times it's changed. It's still that. It's still that entity. And the name change thing is a pretty decent one, right? Doing business as, how do we keep track of this is the same people, this is the same entity, this is the same airlines, to go to our example. A good example is American Airlines, right? So let's use them. American Airlines. And let's go to, if we're lucky, we'll get us a wiki entry from American Airlines. American Airlines. So American Airlines Corporate Affairs. Give me some history. History of American Airlines. So American Airlines has absorbed many different players across its history. I was trying to get a good example of that. A merger with U.S. Airways, merger with other people. They've actually really absorbed a lot of other entities. I'm trying to get a good sense of that. I was hoping to get some like crafty little picture in here, but they're not doing it. Anyway, that's not important. What's important is that, here's one here, like Midway Airlines and Reno Air and Air California and Eastern Airlines and blah blah blah. So you get the point that somebody like American, um, you might actually have to get the history of Reno Air to be able to stitch together a part of their history, or particularly as they've absorbed U.S. Airways. In the last couple of years, right? So that one becomes a really important one, right? And how do you? Here's a great example. How do you reconcile pilot seniority lists and benefits and all these types of things? So those are really good examples of we're going to have slowly changing dimensions, and for the sake of analysis, we really need a smart way to be able to reconcile them. And so that's kind of what. Now, there's also one that just says create a new row. And again, in BI, we don't care about the growth of data. This is not an operational system. We want historical perturbations, right? So here we have the different. See this. See the expiries here: ineffective dates, effective dates. So essentially, we're saying that I'm going to make a new record that sort of says, and a lot of times you see this in your resume and in terms of your employment record, right? Who do you work for? Well, I'll tell you who I work for today, but I've got an employment record. You probably have an employment record. And so this is a good example of we create a new row to keep track of that employment record. Type 2, if you recall, was just create a new row for the new values. And that's what we just did. So we'd have a template that looks like this. We'd have, a schema that kind of looks like that, and we would have that relationship between the slowly changing dimension and the fact table. Type 3, as you might recall, is track changes using separate columns, but override everything else, right? So we would have here the initial row is product technician, and then the original title was product technician. And then we have the current row is product supervisor, and then the previous. But the problem here is, of course, to keep track of every one of them, you're going to have like previous and previous. So a lot of this depends on the nature of the data. Honestly, type 2 makes more sense than type 3 to me. But none of this matters. What matters is that, well, how does this vary with the data? So a template might look like that. Mapping to the dimension might look like that. So um, sometimes these slow changes come with like um, things that change at various paces. So this is another point made in the book. And when they um, kind of have slow changes, then it means that you might want to keep track of these um, dimension changes with two different strategies. So this says that not necessarily type 0, type 1, or type whatever is always like a lockstep best strategy. So for instance, if we think of, maybe this is for the airlines as well, account status, account loyalty level, credit score, income level. I'm not going to hazard a guess as to what this is. I can't remember it from the book. But the first name, last name, I can see those could legally change for different reasons. Marriage is sometimes a trigger for one spouse to change the name. But nonetheless, things like total children probably changes slowly. Birth date probably shouldn't change, right? But account status and all this stuff has a lot more perturbation, a lot more flux. So the idea is that why don't that, and this is actually type 4. Why don't we break these into little mini dimensions, right? If something changes more often, then let's split that apart and give that a different name, right? By giving that a different name, it becomes more manageable. And then we could even further subdivide these because account loyalty and status and all that are one set of information that changes possibly from one source. Credit score, on the other hand, probably changes clearly from having to read external agencies. So we might have value banded mini dimensions, right? And so that means then that we end up kind of keeping different even keys in the fact table to get us into each one of these um, different mini dimensions, right? So it's a value banded mini dimension in that we also might want to kind of create buckets. In this case, the example, they call them profiles. So does this, again, this is a flavor chapter, really. The bigger chapters were 8 and 9, just kind of getting, a sense of how these things might work. So many dimensions can also be outriggers. Here, this is actually an outrigger from the dimension, although it's a mappable straight from the fact table to the dimensions table via the profile key. We can actually then, if we have the customer record up, also reference. So the idea is the sales could have the profile key, but also if we're happen to be in another facet of the operational system or even the BI system, we might be in the customer and then source over to the many dimension. So these are all topologies or schemas just for you to keep in mind. So what types 5 through 7 are just combinations of other strategies, right? So this is an example. Type 5 means that we combine types 1 and 4. Type 1 is override existing data, and type 4 is adding in new dimensions. And so the idea then is that if we had a change in the customer, then we have customer current profile many dimension, and then we just have this generic many dimension here. So this sort of says that we have this difference between their current profile and then maybe more generic profile. It could be because we have some modification to it. Um, Here's an example with sort of these hybrid many dimensions. Um, type 6 is an example where it says let's actually use a combination of 1, 2, and 3, which basically says, all right, well, why don't we um, go ahead and overwrite the data, but also create a new row and also keep track of changes in columns. So if you look at this long enough, you can see examples of each of these, right? We have effective dates and close dates. We have current state of rows. We have the first change in values. So this shows you just how these would modify over time. So we'd have to write, as always, the point is that we keep a schema handy to track these changes. Now type 7 essentially says, why don't we just use both types 1 and 2? And what that means is why don't we overwrite and create a new row for values? And so we can kind of see a schema for that. Now, the last thing, now that we're out of these slowly changing dimensions, and these are all just things to keep track of because the biggest part of these slowly changing dimension types, I'm not going to, well, that's not true. I will end up giving you some kind of quiz on it, but it's not as important that you remember, oh, this is type 3 and this is type 6. What really matters is that you understand that we are keeping track of changes in the dimensions and what is your strategy for that, both in the operational system, but more importantly in your business intelligence system. The operational system will just take it down as some new record. You just have to keep track of, hey, does this mean something in terms of changes to the original entity? So facts, to what do we mean by causal dimensions? Facts have obvious attributes such as product, customer, geography, and time. And this is kind of the who, what, when, where, why, and all that business. In fact, I'm sorry, that's the who, what, when, where. Why, of course, kind of implies that some sort of thought has gone into this, some sort of processing. Basically, something that we record that implies some causality. Why did this happen? So this is the causal dimension. And the causal dimension tells you why a customer bought or returned a product. And so things like promotions, campaigns, reasons for sales and returns. And this is important information, and we sometimes want to keep track of it. So we could say, hey, this was a Christmas time purchase, or this was a discount period purchase. So we end up having, reason codes or promotion keys or anything that kind of tells us, hey, we think that here's an additional attribute you should keep in mind so that you know that this isn't necessarily just some average case sale. So we could handle that with the bridge table, right? So we can essentially say, well, we have, billing line items for our fact table, and we have diagnoses, right? And so the ability to reconcile between these gives us this ability to reconcile between multi-valued dimensions. So this isn't actually, I'm sorry, the causal problem. This is actually with something, a second problem called multi-value dimensions. So when you start to encounter more complicated data situations that require advanced data modeling techniques, you might need to use a multi-value dimension table. And so this is just one example of that. And the bridge table is typically a way to reconcile between multiple dimensions. Now, one last thing that's kind of put up for our consideration is what the author is calling junk dimensions. And so junk dimensions are really, um, miscellaneous. We don't quite know what to do with these. They don't quite make sense into any one entity, but I want to keep track of them. So as a result, we might have to composite our own sort of junk dimension table so we don't lose these. He goes on to talk about in the chapter value band reporting. So value band reporting basically says that we might need some categorization and classification of this data for the purposes of better reporting. I had you guys do that in the airport stuff when I said what continent, and you had to do some of your own aggregation. You had to make your own value bands, right? Which is a way of saying, hey, these countries are in this continent. Um, so you group the facts by some particular dimension or fact measurement. So this is just a good example of value band reporting. There's a couple of different value band approaches, right? We could really look at some criteria to say what is the upper or lower value. We could just go ahead and code them, hand code them. So generally, I like this example because you're usually having some criteria to say, I'll define why they should be in there, and then I'll go ahead and run some query on the data to do that. So we're almost done here. One of the last concerns or topics in the chapter is this concept of heterogeneity in terms of the things that could end up as dimensions. So um, when we have a highly heterogeneous maybe product or service or something that's leading towards our facts, then it kind of creates some issues with respect to dimensions. So the idea here is that if we have a diverse set of products and customers, you might have multiple facts and dimensions. Um, Going back to one of my favorite example sets, um, I I guess I'm a little bit of an aviation nerd, but if I go to the 747-400 here, and if we go down here, we're going to see that it's possible right here. What I'm showing you is that they were delivering this engine, I'm sorry, this airplane with different engines, right? So the idea is the customer could specify any number of, not any number, but three different engine manufacturers. I was trying to look for an example of that for you in the entry, but they're not quite doing that. You can kind of see it in here, but that's not important. What's important is that um, you could have the one product actually kind of have multiple internal configurations. So that's the heterogeneity in the product is that it's configurable. I mean, look, if you buy an Apple laptop, for instance, um, that's a good example of something that's pretty much got some heterogeneity in terms of how it's configured. So you might want to design your schema for that so that you could basically hot swap in these different dimensions that vary within the product. And there are other examples. You could actually just merge them into one big fact table, and that's one way to go. You could create separate dimensions and fact tables representing the diverse businesses, or you can create a single dimension and then a single fact representing of each one. So these are just different strategies for that. So the big picture with Chapter 10 really is this. The big picture of Chapter 10 is just a couple of other concerns when you're thinking of dimensional modeling. But to kind of return to the basics here, what we're dealing with in um, in this whole section of the book is there's management of data. Typically, we're talking about entity relationship modeling, and so that has to do oftentimes with operational data. There's a picture back here. I can end up on the picture here, way back in the beginning of the lecture, way back in the beginning of the lecture. Way back, way back. This is not really what I'm looking for. I put it in at the beginning of chapter. No, it was in 9. Oh, did I lose it already? Yeah. So your operational systems, we're going to end up doing that ER modeling, and that has one purpose. But then the modeling you're doing for business intelligence and analytics is, a second style of modeling, and we've seen both of these here in these chapters. And so 10 was just giving you some extra thoughts about different things you're going to run into. All right, I'm going to cut that off. This is enough. Um, expect some videos on 11 and 12 quite soon, and then some new work to do related to those. All right, thank you. Take care.